This is Duke University.
I was really thrilled when Bill asked me if I would come down and speak about nutrient issues, because this is one of the set our priorities in the Office of Water at EPA, is to address the nutrient problem. So I'm not sure of everybody's background here, so I hope that, I'll sort of do the middle ground and talk a little bit about why we have a nutrient problem in this country, and then really focus on what EPA is doing, and hopefully leave some time for questions. And I know many of you in this audience are working on addressing the nutrient issues in North Carolina or elsewhere. Oops. Okay. Now, where do I need to push this? This one? Okay. So I'm going to talk a little bit about the national scope of the nutrient problem, the public health and aquatic impacts, what are the sources of nitrogen and phosphorus, and then what can we do about them. And maybe you'll have some ideas for me as well. So the problem, this is going to, you might want to, I do have some really pretty pictures of nutrient pollution. So figuring that a lot of you are water professionals, environmental professionals, you've probably seen some of this. An issue with the general public is the general public thinks nutrients are good. I mean, nutrients, that's what, you take vitamins, you're always looking for nutrition in your foods. But so it's really important to show folks how you can have too much of a good thing, and obviously this is too much of a good thing. So the national scope of the nutrient problem. We have very well documented problems and impacts of nutrients. EPA has done national assessments. We did a wadable streams and lake assessment twice now. We have states have their own water quality assessments they do every year showing nutrient impairments. There was a recent, very excellent USGS study put out in 2010 that looked at the impacts of nutrients on groundwater, and that really talked about the drinking water link, like high nitrates in groundwater wells that people are drinking. A lot of state and university reports, and then EPA and the states had a nutrient innovations task group. And I don't know if any of you had seen this call to action report, which I actually helped write when I was with the Commonwealth of Virginia. And that was really an excellent grouping of states and EPA putting their heads together on summarizing the problem and then what we can do about it. This is really an underestimate, 14,000, I think we're over 15,000 now, nutrient-related impairment listings in the states. That includes 2.5 million acres of lakes and reservoirs, 80,000 miles of rivers and streams, and that's only the ones we've assessed. Think about all the rivers and streams and lakes you don't get to assess, because there's no way you can assess all your river miles. For instance, 78% of assessed coastal areas exhibit high nutrient eutrophication symptoms. We have hypoxic zones in U.S. waters that's with no oxygen, no or low oxygen, and contaminated drinking water. So this really has become a very serious problem. Now this is a really interesting map because it shows, this is the results of the Wadable Stream survey that EPA did with the help of the states. And it shows where the highest concentration of nutrient problems are. And you can see there, certain pockets, but really all over the United States. But I do want to point out a couple things. Like, for instance, you may have heard that Florida has a nutrient problem that EPA is working on. The reason this doesn't show here is because the Wadable Stream survey was a probabilistic sampling survey, and no points were in Florida. So I always like to say this with this chart because it could be misleading, because you could think there were no problems. So where there's no dots, that really just means there was no samples included in the statistical survey. This is the USGS report I was referring to, which you really should read if you haven't, because what was alarming, I think, is that they showed that the nitrate maximum contaminant levels were exceeded in 7% of the drinking water wells they sampled. And nitrogen concentrations were very high in streams and agricultural areas, not a surprise. And you know, we're feeling like these nitrate concentrations are going to increase, and you know, nitrate can cause blue baby syndrome and other health effects if it's in your drinking water. This is a Woods Hole study that looked at algal bloom occurrences in the United States, and I'm sure this audience is not surprised that you get algal blooms inland, but you know, some people always think that's just going to be on the coast, but you have really pretty significant algal bloom breakouts all over the country, and you know, related. We certainly believe those are related to nutrients. And in terms of why is this significant, I mean, it's a health effect because you can have toxic algal blooms, but also we've estimated that these blooms can cost the U.S. economy between $2.2 and $4.6 billion annually, both in cleanup and in lost revenue because people can't go to beaches, fish kills, you know, so you can't do recreational fishing and commercial fishing. This is the national drinking water impacts. I mentioned the nitrate violations already, but also disinfection byproducts. You've all heard of the concern everybody has with all these you know, nanomaterials and endocrine disruptors and other things that are in our waters, and they're very hard to remove. So when we have to treat water to remove the nitrates, you get your disinfection byproducts, and then what do you do with them? So it really increases the treatment costs and also the worry about what to do with byproducts. And just to emphasize the drinking water issue, you can see the increasing trend of nitrate violations in community water systems, drinking water. That's pretty alarming. Okay, again, some pretty algal pictures. These are from Kansas. Just not around here, but they could be around here, I'm sure. And this is an example from Lake Erie and the Toledo water intake with a microcystis bloom, and I don't think anybody wants to be drinking that glass of water. And I don't know if you've heard about the what they call the other Great Lake in Ohio, which is Grand Lake St. Mary's, and that's a very large lake that a lot of people use for recreation, and I think they had to close it down this summer because that's what they got in terms of algal blooms, and I believe they just recently treated it with, they did a alum treatment for the whole lake. Just, I mean, I read about it in the paper. Yeah. And that cost $5 million for them to do that application. Well, $5 million to do that, and then also they lost 2,500 jobs and $200 million in annual revenue from recreation because they had to close down the lake this summer. So Ohio has been aggressively looking at the nutrient problem. And here's some examples of impaired streams, again from Kansas. Yes, we got them to volunteer their pictures. Nobody else wanted, no other state wanted to show their pictures, but that's not a pretty sight. That's not what a stream is supposed to look like. And we also see, and we also see impacts on downstream waters. This is from Florida, the St. Johns River, and this is an extremely long river. It flows 310 miles through 2,000 square mile basin, and algal blooms have occurred all up and down it, but you know, the nutrients are coming from upstream and traveling downstream and causing the algal blooms at the mouth of the river. Okay, so where are all the nutrients coming from? Well, one obvious place is wastewater, municipal wastewater treatment plants. Now, wastewater treatment plants are heavily regulated by the state and federal government. They, you know, you see you have greater than 16,500 municipal treatment system permits. About 7% actually have numeric limits for nitrogen and phosphorus. That's one thing that we want to look at EPA, working with the states, is to increase the number of treatment plants that are removing nitrogen and phosphorus through advanced treatment. It is costly to do, but it's, you know, an effective way to regulate. Plus, it's through permits, so it's easier to regulate. Atmospheric nitrogen deposition, that's been shown to be a very significant source of nitrogen in waters. In the Chesapeake Bay, it accounts for 21% of the nitrogen that's in the bay. That's huge. And, you know, how we get to that is through air regulation. And if you've been reading the newspaper, you can, you understand how air regulations tend to be fairly unpopular with the industry, maybe popular with the citizens who would like the particles in air removed, but you know, this would be like by putting scrubbers in power plants to remove nitrogen and things like that, would decrease the amount of nitrogen getting into our waters. Urban stormwater is a huge source. Stormwater as a whole is a huge source of nitrogen and phosphorus, because in general, stormwater is not regulated. It's not considered a point source that is under permits from the states, state or federal government under the NPDAT system. So 80% of the population lives on 10% of the land, and 50% of the existing urban landscape is going to be redeveloped. And all that, like we have permits that are required during construction, but not once you're in operation. The runoff from your parking lots and things like that are not really controlled unless you're in, right in a city where they have a permit. It's called a MS4 permit. Don't ask me what the 4 S's are on that. I always get that wrong, but it's a municipal stormwater permit. But other than that, if somebody develops a Walmart out in suburbia, they have a permit when they construct it for the stormwater, but then there's no more permit. And so you get a lot of runoff that way. Agriculture is a huge source of nutrients. As you probably know, aside from the certain animal feeding operations, agriculture is unregulated in terms of you know, water pollution. So the row crop industry as well, you get fertilizer runoff, you know, you get runoff from animal feeding lots, and that's getting into our waters that has a high nutrient content. This is just to show you a little bit about two heavily studied areas, the Gulf of Mexico and the Chesapeake Bay. And it also shows you that, you know, different watersheds have a different percentage of their nutrients coming from different sources. So, and this probably isn't surprising, the Gulf of Mexico is dominated, nutrient sources are from agriculture, from crops and livestock. And the urban sources are very small, whereas in the Chesapeake Bay you can see that the agriculture sources, while significant, are less than combined the wastewater and stormwater. So you have to use different tactics to approach control of nutrients in different watersheds. So it's really important to know what your sources are. So in the larger context, you know, why now? Why is EPA focusing on nutrients and asking the states to do the same? Well, there's several reports that have noted the nutrient problem. The Inspector General did a report that looked at saying that EPA's strategy to control nutrients through water quality standards has been ineffective, and that a lot of states have no numeric criteria that you can judge whether you have a nutrient pollution problem against and control it, that we're not holding the states accountable, and you know, told us that we need to do a better job. I mentioned this state EPA Nutrients Innovation Task Group report that said that there's existing tools under the Clean Water Act that are not being used to the fullest extent that we could to control nutrients, and that also we might wanna look at new ways to share accountability for sources of nutrients. And there also has been growing stakeholder pressure for EPA action. And here's, probably this is just a partial list of the litigation. How many lawyers are in this room? So I won't say too much, but you know, this, to us, this shows that the public is concerned about the nutrient problem, and that we're not doing enough, because if we were doing enough, there wouldn't be litigation to do more. So there have been various petitions to ask EPA to step in certain states to try to do more with the nutrient issues. And some of the probably more well-known litigation, the Mississippi River Watershed Petition, which was filed several years, 3.5 years ago now, where the petitioners asked for EPA to step in and do numeric water quality standards for nutrients in the Mississippi River Basin states. And we just recently, well, I guess it's not so recent now, last July, we replied to that petition and said that while we certainly agree that it's a serious problem, we believe that the states should take the lead in addressing that problem, and that we stand ready to work with the states, but we are not ready to step in and do the job for the states. So I'm going to be telling you a little later all the things we're doing to facilitate looking at nutrient issues in the Mississippi River Basin and elsewhere. And then we had a petition in Florida where we did end up stepping in and developing numeric nutrient criteria for Florida. And we're still in the process of doing that. But the good news is in Florida that Florida has stepped up to the plate, and they are working to develop their own nutrient criteria that are very similar to what EPA has worked on. And in fact, in many cases, you know, we worked together and they used our models and data. So we're hoping that that will get through their legislature and will be passed, and then that EPA would be able to approve those, in which case we would withdraw the federal action. So again, the idea is the state should be doing it. But in Florida, the situation was so widespread, very serious nutrient enrichment all over the state that it was felt EPA made a determination they needed to step in that case. And then there's other lawsuits that I'm not going to go into, but you know, that's a better way to do business, is to address things proactively rather than to end up in the court system. The nutrient problem's not going to go away. Our population is growing, as we talked about. One of the major sources of nutrients is urban and suburban stormwater runoff, so that's going to increase with increasing population. Agriculture is going to increase with increasing population, so it's not like our sources are going to go away. All right, so what are the tools to address nutrient pollution? I'm assuming everybody in here knows what a TMDL is, total maximum daily load. That's where you determine, I guess we coined the term pollution diet in the Chesapeake Bay for, you know, how much sources of pollutants can a water body withstand and not suffer the ill effects of it, you know, the tipping point. So TMDLs, like the Chesapeake Bay TMDL, the bay's impaired, it's polluted. Now we know what the levels are that we have to get down to turn it around. And so you assign loads to the sources and sort of work backwards. So TMDLs work, but the thing is, you have to wait till there's a problem for a TMDL. So why would we want to do that in waters that are healthy right now? We don't want to stand by and watch them suffer from nutrient pollution until you start seeing the fish kills and the algal blooms. We'd like to be preventative medicine, so to speak. So TMDLs are good when you have an impaired water body already, but you don't want to wait till you get to that point. Permit limits, yes, we can put limits in the wastewater treatment discharge permits that control for nitrogen and phosphorus. couple problems. One is that without a number, a nutrient number to shoot for, it's really hard to know, like, how do you tell a sewage treatment plant what level of nitrogen or phosphorus is going to be appropriate for their discharge, and that's why numeric criteria or loads estimates, as we have in the Chesapeake Bay, are good to have. And also that works for the permitted universe, but you saw that a lot of the sources of nutrients are unpermitted facilities or unpermitted sources. Another tool is to look at best management practices in priority watersheds, and we are doing that. I think I'll tell you a little bit later about what we're doing with USDA on looking at putting best management practices on agriculture and on stormwater to decrease the amount of nutrients coming in. And then another tool is these nutrient criteria I told you about. So water quality standards are set for all different parameters, and that says what is the amount of nitrogen, phosphorus, oxygen, whatever, that pH, that will allow that water body to be healthy. And if you go over that point, you're not gonna have a healthy water body. So that's your criteria, and they can be either narrative, where you talk about goals like you want your streams to be fishable, swimmable. That's pretty much the basic goal. Or, you know, that they can be numeric, which says this water body has to have an oxygen concentration of 8 or above to be healthy, or a pH of 7 or above, or whatever. And if it's numeric, that makes it easier to assess against versus narrative, where you have to make a judgment call if you, another water quality standard is it, the water should be free from harmful algal blooms. So what does that mean, free from? I mean, it doesn't mean 0, and but it certainly doesn't mean 100, so somewhere in between. So that makes a judgment call. So this Nutrient Innovations Task Group report that I told you about talked about the various tools that exist that we're not using enough, that we could look at and use more. And so partially utilized means that we're already using them, but maybe we could do more. NPDES are the discharge permits that I was talking about for the point sources. So when we say partially utilized, we could do a better job by putting nutrient limits in those permits, and that would really, set a target for controlling nutrients from those sources. Numeric nutrient criteria, which is what I just talked to you about, that taking the narrative free from harmful blooms and unbalanced communities is another one that's used often, like an unbalanced biological community, but what does that really mean? And getting more specific on that. We can use assessments and listings, so states go out and do, every year they assess a portion of their waters. They go out and take samples of the water, the sediments, the biology, and then they compare that against their standards, and they list waters that are impaired. So that's a good tool to show where your problems are, but with budgets decreasing, it's hard to get to all your waters. So we could probably do a better job on that. The total maximum daily loads, we have lots of impaired waters, but we haven't gotten around to doing those maximum load calculations for all those impaired waters because there's so many of them. So, because once you get a TMDL in place, then you have a mechanism to put limits on your sources. And, we probably should look more at the livestock industry, the part that's under these CAFO permits, the confined animal feeding operation permits, and do a better job on those. What we believe are underutilized tools are stormwater controls. We could look at technology-based requirements, like maybe you put on treatment plants that everybody has to install biological nutrient removal, for instance. That's not a requirement now. Limits on discharges in impaired waters, and applying anti-degradation refers to there's a requirement in the Clean Water Act that you can't further degrade a water. So through your standards, that's how you protect your waters against further degradation. And many states don't use that tool to its fullest extent. So I think I already told you about this NITG report that, which again I commend to you. It's on our EPA website, and this is where we talk about that all major sources of nutrients should be held accountable, that we need a change in how we look at this problem, and that we need national leadership, states and EPA working together to fully utilize the tools available. And again, I think I talked to you about this, about why we're looking at this now. The problem is here, it's a growing population. So last March, EPA issued what is fondly called as the Stoner Memo, and that's after my boss, Nancy Stoner, who's the Acting Assistant Administrator of Water. And this is, again, it's a March, I think it's March 12th memo, March 16th, one of those. But it really lays out, it was a memo to the EPA regions, but it's really for everybody, and it lays out what EPA's framework is in addressing nutrients, because we're not just doing one thing, it's not just permits, it's not just assessments. So what we're looking is to get results building from state work, but trying to accelerate the progress of state work where needed. And it encourages a collaborative approach and flexibility in approaches. So I just want to go through what the elements of the framework are. The first is that states should prioritize watersheds on a statewide basis for their reductions, because you're not going to have nutrient problems everywhere in your state. Well, some states might, but many states won't. There are some areas, I'm sure in North Carolina, many of you experienced people in this room would know, just, off the top of your head, where some watersheds are that have the most nutrient problems. And it's really important on those to, assess those watersheds, estimate how much nitrogen and phosphorus are coming into those watersheds, and target them for activities. And that's really the best, you have to start somewhere. So we really support a targeted watershed approach, where you look to reduce all the activities in a certain watershed to reduce the pollution problem. And in order to do that, you really need to set a watershed load reduction goal. And you could, obviously a TMDL sets reduction goals after it's already impaired, but you can do that without a TMDL by looking at, where you could set goals for how and where you could decrease your nutrients. Once you have your targeted watersheds, the first thing to do is look at your point source permits, because again, that's where you can put the limits in existing permits. So you look at your municipal and industrial wastewater facilities, your concentrated animal feeding operation permits, and your urban stormwater. Those are the MS4 permits I talked about. And that's what, do you need to put nutrient limits in those permits if nutrients are a problem? Then you look at your agricultural areas, and EPA's been working really closely with USDA in this, and we have, especially in the Chesapeake Bay and in the Mississippi River, we're looking at combining what we call 319 grants at EPA, which are non-point source grants to watersheds, and then also USDA Farm Bill. And those monies can be used for different things, so we look at combining those monies to partner and to use innovative approaches, environmental markets, put in best management practices, and accelerate adoption of effective conservation practices. And I think that's already been an effective way to go about it. USDA is really putting a lot of emphasis on this, which is really good. And then also we want to reduce stormwater runoff and septic system impacts. I know, like in the Chesapeake Bay, the leaking septic systems have been a big source of nutrients into the bay. So there's pump out requirements and replacement requirements, and getting better systems in place. even like nitrogen removal in septic systems. No framework is good without accountability and verification measures. So you can put all these measures in, but we need to know what's happening. Are we getting improvements on the ground? And that's part of this targeted watershed approach that USDA and EPA is working on with the states, where EPA cannot use their 319 money for monitoring. It's for planning and putting in practices, but the Farm Bill can do monitoring. So we're combining and doing like edge of field monitoring for agricultural systems to look at if a best management practice like a buffer or no-till and those things are really keeping nutrients out of the water. So you can see your results. You need to verify the load reduction practices are in place and assess and demonstrate progress. And you want to be transparent to the public. That's really important too. So you need to publish your implementation activities. A lot of states do that already. EPA does it. And to really share what's happening and involve your stakeholders. We're also looking at a work plan, like for states to have a work plan and a phase schedule for developing numeric criteria for classes of waters where they need those criteria to drive improvements. And we understand that everybody can't do that right away, and that maybe in some parts of a state where there's not a lot of pressure on nutrients, you might not have to adopt numeric criteria, and we're willing to work with states to do this. A recent example of where we worked with the state of Montana, they developed very excellent scientific-based and very strict nitrogen and phosphorus numeric criteria for their waters, lakes, and for streams. And when we looked at those numbers, everybody realized, wow, facilities are not gonna meet, we can't put this in permits because, you know, there's, the state of Montana isn't rolling in money, and they're not gonna put advanced nutrient treatment in all of their systems right away, or requirements on agriculture or whatever. So we work with the state, and they actually have a statewide variance based on widespread social and economic hardship, that they could not implement these criteria immediately, and we came up with a schedule with them of how to phase these in and have interim steps. And so they have excellent criteria on the books now with interim steps on how to meet it. So we really feel like the Montana example is a good one, and Richard Opper, who is the Montana Environmental Director and former president of ECOS, the Environmental Council of States, has gone on record saying what a great approach this was and how EPA really worked in a partnership. And that's an example of this framework of what we're looking for. So we're really thrilled to have that. And we're working with other states on a similar model. So in terms of these numeric nutrient criteria, this does show you that most states are working towards criteria. Sorry that North Carolina doesn't have any dots in it, but a lot of states have, 23 states have some form of numeric nutrient criteria that are water body specific, like for lakes, or for like phosphorus in lakes, or nitrogen in a certain bay. 7 states have EPA approved numeric nutrient criteria statewide for one or more water body types, and 16 states have numeric criteria for a specific water body. So we're moving in that direction, and it shows, again, you know, through adaptive management, you need to look where your problems are first. And, you know, sometimes problems are not statewide, they might be water body specific. So you need to tailor your remedy to what the water body is. And I talked a little bit about federal resources to help states tackle the nutrient issue. There's Water Quality Management Planning Grant 604B. There's the Section 106 grants. That usually covers permitting and monitoring for the states. The 319, which I talked to you about, is non-point source implementation grants that help plan and get BMPs in the ground. revolving fund programs, that's where, EPA provides money to the state that's then used to give, low or no interest loans to, wastewater treatment plants. And in some cases, for agricultural BMPs, I know in Virginia, the SRF was used to fund agricultural BMPs as well. You know, that way, it makes it easier for localities to afford, to be able to control nutrients. I mentioned the Farm Bill, and again, we've never worked as hard with USDA, and they really are committed to, working together to tackle the nutrient issues and to target Farm Bill dollars where the most nutrient problems are. And that's not an easy thing to do because traditionally USD funds have not been necessarily targeted in the areas where there are the most problems. And USGS, we're working with them on a cooperative monitoring program, and the Corps also has some resources. Those I think are planning dollars to look at watershed planning. We also have EPA technical assistance. Am I doing okay on time? We've developed a data access tool, and you can go, we have a nutrient pollution part of our website that you can explore. But what we did was we put together data that was already out there and was publicly available. This is not new data, but we put it into a data viewer. So you can like click on your state and look at, you know, what watersheds have nutrient impairment, you know, where, it's a good planning tool to see where are your areas of most vulnerability for nitrogen and phosphorus pollution. So it supports states as they work through their framework to consider the magnitude of their problem, their vulnerabilities, and the sources. So it's pretty cool if you have time to take a look at it. And I wanted to close by talking about two huge EPA state initiatives, the Chesapeake Bay and the Gulf of Mexico Hypoxia Task Force. And I've been fortunate enough to participate in both of those. So the Gulf Hypoxia Task Force is really a unique task force because it has federal agencies, tribes, and state agencies. And the neat thing about the state agencies is it's split between the agricultural secretaries and the environmental secretaries. So that's very unusual to get all those secretaries in a room together. So they rotate for each state, like for 2 years, the ag secretary will be on the task force, and then they'll switch over to the environmental secretary. So you really get some good synergy, and you know, you hear it from both sides, so to speak. And so you can see those are the states that are contributing to the hypoxic zone that's in the Gulf of Mexico that's threatening, you know, recreation and commercial fisheries and all that in the Gulf. So this is the extent of the hypoxic zone off of in the Gulf. And it extends from very near shore to quite a bit offshore, but that's all being affected by all the nutrient dynamics in all of the states in the watershed, and the watershed is like half of the United States. So pretty much takes up a lot of states. So what we've looked at is, you know, what needs to be done to reduce loads from, and you saw earlier that most of the sources are agriculture. So what can you do to reduce loads? Well, think about how long it would take to do a TMDL. Any of you who have worked on the Chesapeake Bay TMDL, which is me included, I mean, it's just an impossible task. So rather than wait to do a TMDL for the whole basin, we're looking at developing target goals to reduce nitrogen and phosphorus that will obviously improve the situation in the Gulf. And we're doing it like through modeling and, you know, how much will we have to reduce. So the task force set this very ambitious goal of reducing loads from upstream ag. And, you know, we want to just, you know, get practices in place and see how we're doing with it. So there was a 2008 Gulf Hypoxia Action Plan that was worked on with the states and all those federal agencies. And actions to achieve the goals in that plan are to develop and implement statewide nutrient strategies, to track progress, and to really focus on the voluntary and adaptive management approach rather than the hammer, more the carrot approach than the stick. So, and to do this is why we're targeting these Farm Bill and $319 to help states develop these frameworks, and we've put out various grants that states have applied for to work on frameworks and get some reductions in place, and then we can reassess where we are rather than waiting. The Chesapeake Bay program analysis started in 1980, because that was like my first job when I moved to Virginia, was working on it, and it's still going on. So rather than take all that time to do the studies, we know more about the problems now. Let's just start addressing them to the best we can and see where we get. Mississippi has really led the way. They've done a tremendous amount of work, the state of Mississippi. They completed their strategy development and they're moving to implementation, and they're looking at putting in best management practices for agriculture. The other task force states are at various stages of the development process. You can see that here. Of course, with the economy the way it is right now, it's really hard to get the resources for the planning, but it's also very important to these states because it does affect their economy. So we're working on this task force. We have a meeting coming up in Memphis. We meet twice a year, face-to-face with these folks for check-ins, and then we, talk monthly and looking for, how we can help the states get these improvements in place. And these are just some of their recent actions that support the nutrient reduction strategies. Okay, so I promised I would close with the Bay. We've been studying the Chesapeake Bay for a long time and started this cleanup mode in the early 1980s. It's interesting, in the Bay, they never had numeric criteria for nitrogen and phosphorus. But what they did in the Bay was they used the dissolved oxygen and submerged aquatic vegetation and chlorophyll A levels as surrogates for high nutrients for nitrogen and phosphorus. So there was never an actual numeric criteria for nitrogen and phosphorus, but there were for those other parameters I just mentioned, and those are indicators of nutrient pollution. So there's states, as we talked about state flexibility, that's a way to get to the same place, because we were able to calculate loads for nitrogen and phosphorus for point and non-point sources by basin based on those surrogates for nutrient impairment. And the strategy relies, so now the TMDL is in place, there's endpoints, loads that you're supposed to reach and how you're gonna reach them. We're looking at an adaptive management strategy, allowing the states to put in controls and see how they're doing. And then EPA has certain backstops they've articulated to the states, like, stepping in to require more permits or stricter permits or things like that. So this just is an example for dissolved oxygen, the criteria, like what levels you need to support certain species. And this shows the Bay TMDL schedule. So the TMDL's done. It was EPA did the TMDL, but it was with a lot of state involvement. And then the states developed these watershed implementation plans to show how they're going to get the improvements required by the TMDL. And now they're in phase 2, which is to implement the watershed plans. And then in 2017, we're going to have a relook. But in the meantime, every 2 years, the states are going to have to report on how they're doing. They have milestones, very specific milestones, and if they don't reach them, we're going to take corrective action with them. But in 2017, they're supposed to have 60% of what they promised in these WHIPs. They're supposed to have 60% in place. And then we're gonna have a relook at both the widths and probably also the TMDL to see if it needs to be adjusted. You know, there's a lot of issues involved with the modeling, and nobody ever thinks a model's perfect. But again, right now, we feel it's important to move forward to address the nutrient problem. And this is the adaptive management approach, which looks at the Chesapeake. I know some of you in this room have been very involved in this. I'm looking at Ken in particular. But what's really neat about this model, they have this something called a scenario builder, where you can look at, like a state can look at what practices they would put in place and see what the outcomes would be if all of those are in place and effective. So then they say, well, maybe that's not the right mix, let's tweak it. So I think that's you know, pretty innovative approach, because again, you don't want to just wait and see. If something's not going to work, it would be nice to know before you put it into place. So while there's, you know, as I said, there's problems with any model this complex. It's never going to be perfect, but remember, it's a model. And if it can get you to the next step, I think that's pretty good. So this just shows that feedback loop, that if you're putting all these practices in and you're not meeting your water quality standards through the model, then maybe you need to go back and look at your inputs again. So that's, in a nutshell, some of the things we have been doing, EPA with the states. What are we going to be doing looking ahead? We're really going to try to focus more on drinking water and ecological risks and economic impacts documentation. We want to make sure the public understands that if we ignore this nutrient problem, we're going to see public health effects, we're going to see economic effects in your fisheries, recreation. It's going to mean something to people and their health and the economy if we don't tackle it. So we're looking for more documentation of that. As I said, we're doing a broader EPA-USDA coordination. We're really working closely to target watersheds and use our resources together. We have a continued commitment to science. Science is behind all of this, so we really need to continue getting better science on, like for instance, these best management practices that are put in for stormwater and for agriculture. How do they really work? You know, do they have a lifespan to them? You know, after a while, do they not remove nutrients as much? You know, how effective are they? And that's particularly important in a trading context where if a point source has a certain nutrient requirement and they buy from like a landowner, they pay a landowner to put in best management practices to reduce nutrients that would satisfy their permit requirement, we need to make sure that those reductions are real because they're in a permit context. So science in that regard is you know, an area we're focusing on. Looking at the nutrient management frameworks, we're really working with the states, making a big push on this through our regional offices. Looking at where state numeric nutrient standards would be best applied, and reaching out to stakeholders, and then this whole issue of stormwater. Some of you may know that EPA is working on a stormwater rule. We've been working on it for a number of years, and we continue to work on it. It's a tough nut to crack. Because that, you know, stormwater is pervasive everywhere and it costs money to control it. But what we're trying to look at now, we're refining our cost-benefit analysis to show what are the benefits of that cost that the development community would incur by controlling stormwater, and the benefits to water quality, to fishery resources, to flood control, for instance. I don't have to tell you in North Carolina the cost of flood control, because you've had quite a few really bad floods. So if we have ongoing stormwater controls, is that going to prevent flooding? And that has an economic value to it. So that's what we're working on now. And in fact, we recently convened a couple panels of experts to pick their brains on how we can look at those benefits. So that's one of the things I've been spending a lot of time on. So for more information, you can go to our water science website, and I think it was more the nutrient one, has the all the general things. And, EPA is always glad to talk about what we're doing on nutrients. And as I said, we're working very closely with states, including North Carolina, on this nutrient issue. So with that, I'm happy to answer your questions.
Produced by Duke University, online at duke.edu.